Today's lesson is Inequalities with Set and Interval Notation Day 2, so a sequel to our Day 1 lesson. Keep the following ideas about set notation or interval notation in mind. Okay, so first, most of the time, it is possible to list solutions as elements in a set. So for example, you're only going to have maybe 2 answers, or there's 4 answers, or there's 1 answer. And if that's the case, here are some examples of how you would write them. You would just list them inside a set of squiggle brackets. Now you're going to notice in the second example here, we used an ellipsis in the center just because then we show that we're using the same pattern, but then when we get to 10, we're stopping. You could also list those all out separately. Now 2, when a solution set is not possible to list, then you use set notation or interval notation. Okay, so set notation, the way you set it up is written underneath. We did have a previous lesson where I gave you a very quick preview. Set notation is using the squiggle brackets. You're always going to start with your variable symbol. Then you are going to put the number type. This vertical line is usually read as such that. And then after that, you're going to have a description, which in most cases will be an inequality. Okay, and then interval notation, we briefly talked about in the previous lesson. If you want to go back and take a look at that table, remember the main idea here is that if we have greater than or less than, that converts into the use of parentheses. If we have greater than or equal to or less than or equal to, then we have a different situation where we need to use brackets. Okay, so we're going to look at some examples underneath of both so that you understand and have some comparisons. The first example says x real such that x is greater than 0. That's how I would read that. So we're going to write what that means on the other side here. X is all real numbers greater than 0. So in set notation, we have it like this, x real such that x is greater than 0, or we have interval on the other side, which is showing you that 0 is your lowest number, that's why it's on the left. You are going on for infinity, that's why you see the infinity symbol, and neither of those are included, which is why you see the use of parentheses. Next, we have p integer such that -3 is less than or equal to p is less than 100. Or in interval notation, -3 with a bracket around it because it was included with this symbol, and then 100 with parentheses around it because 100 is not included. Okay, so again, set on the left, interval on the right. So for this one, we have p is all integers this time. So they're restricting us a bit by only allowing us to use integers. So p is all integers greater than or equal to -3. Okay, but we also have to get the other part in, which is and less than 100. And less than 100. Our next example, we have y real such that y does not equal 0. Or, similar to what we showed you in the previous lesson, we're going to start from -infinity and work our way up to 0, neither of them included. Then we're going to union that with 0 all the way up to infinity. So the way you would write something like this, if you recall, is just saying what you cannot be. That is the shorter way to write this. So you would do y is all real numbers but we would just say except 0. Okay, So a few notes on graphical representation when it comes to these kind of situations. A solid dot, remember, denotes points on a number line, real numbers that would be included in the solution set. And if we have open dots, that indicates a point that would be excluded. It does not count, which we have discussed. So here is the graphical representation of a set of real numbers. We're going to go through and try to read this graph and write some different scenarios in set and interval notation as well as words. So A says, describe the set of real number in words. B says, describe the set of real numbers in set notation. C is interval notation. And D is write an equation or inequality that would satisfy this. I find to write the inequality first is my way that I like to proceed. You can do any of these first, but I'm going to start with what I'm most comfortable with and probably what you're most comfortable with, which is the inequality. So what I'm seeing in the picture is a closed circle, which means 2 is included, and I see all of the numbers that are less than 2. So this is x is less than or equal to 2. So me reading that to you gives me part A, describe the set of real numbers in words. So now I know it's x is all real numbers less than or equal to and we have 2. All right, so now it says describe the set in set notation and interval notation. So if we do set notation, remember this is using our squiggle brackets. We're going to do a squiggle bracket. The first thing you write is the variable. So we chose x. Then we're going to say what kind of what kind of number it is. Ours is real. Then we have our such that symbol, and then our inequality follows. So we already wrote that. So that's why I like to start with the inequality, because it's already written, and we can go ahead and put that in. And then describe the set in interval notation. We want to think about whether 2 is the lowest or the highest value. It turns out it is the highest this time, so it should go on the right-hand side, coming from negative infinity. Infinity is never included. You can always find another value. The 2, however, is included. We have or equals to and a filled-in circle. So there's an example of all notations with the graph that you see above. So now in example 2, we're going to add in our solving that we've done in previous lessons. So I want to look at this, and we are going to go ahead and write it in words, set notation, and interval notation, and graphically. So this time we have 4 things we need to do. So we're going to do it in words, set notation, interval notation, and graphically this time. So I'm going to start with simplifying as much as possible before I start solving. I see distributive property. So 2 times 2x is 4x. 2 times negative 8 would be negative 16. Then we have minus 8x is less than or equal to 0. Now I would check for like terms. On the left-hand side, I have like terms. I can combine 4x and negative 8x to make negative 4x minus 16 is less than or equal to 0. So then, starting to isolate my variable, I would add 16 to both sides. Whatever I do to one side, I need to do to the other. These are eliminated. And then I need to divide by negative 4. So this is important. This is dividing by a negative number, which in a previous lesson we discussed means the inequality symbol needs to switch directions. So these negative 4s are gone. And we have x, and we're going to switch the symbol to greater than or equal to 16 divided by negative 4 is negative 4. So in words, we have x is greater than or equal to negative 4 as our words. Then in set notation, that means squiggle brackets, the variable, the type of number it is, which is a real number, such that, and our inequality is going to go in the next position. So x is greater than or equal to negative 4, and close our squiggle brackets. In interval notation, we have to think about, since this is an open-ended one, it's not a sandwiched one, that negative 4 is our lowest value, and all the x's are greater than that. So negative 4 should be on the left, going towards infinity, Infinity is never included, but the -4 is included because of the or equal to, so that will be a bracket. When we graph this, -4 is included, so it will be a closed circle, and then we will shade towards all the positive side of that value. So a few additional notes I want to talk about to finish this out. Remember, it is possible to have no solution. So because we have this situation, I want to talk about what it looks like in each scenario. So when you have no solution, okay, you can actually write no solution as your answer, but another thing you might see it called, and you can refer to it is called a null set. So both of these would be what you would write in words. You can use either one of them. As we've discussed previously, you can make empty squiggle brackets. Okay, this is typically used as set notation, as you can tell by the squiggle brackets. The other one we have showed you is a circle with a slash through it. This one specifically is used for interval notation. And then remember, if you have a graphically, and you're going to show this, let's say we have something like that, you would just leave a blank graph. So this is your graph, and you leave it blank. So just wanted to bring back in that no solution and show you what they look like and all the different notations that we've been practicing. And that concludes your lesson on inequalities with set and interval notation, day 2.